So in this video, we're going to be looking at something called the discriminant. So first of all, the discriminant has a formula which looks like this: b squared minus 4ac. And sometimes you'll see people write it like this: d equals, and d essentially stands for the discriminant. Now, if you have seen the quadratic formula already, you'll notice that this is actually what's under the radical of the quadratic formula when we use that formula. So that's where this is taken from. Now, the discriminant tells us a bunch of different things. It actually helps us choose our method for solving a quadratic. So choose our method when we solve a quadratic. All right. So first of all, let's get down what it actually tells us, what the answer for the discriminant tells us. So we can break it down in a big chart. I'll try to make it as nice as possible. So the first thing it's going to tell us is this. So when d is greater than 0, and it is a perfect square. So a perfect square. Okay, so let's say we find the discriminant, and the discriminant's something like, I don't know, 36. Okay, if the discriminant's 36, it tells us that we have two roots, or two x-intercepts. We have two values for our x's. Okay, now it tells us that those roots, if the discriminant is bigger than 0 and it's a perfect square, it means we have two answers, or two roots, and they are both rational. Okay, so they're both rational answers. Now, the same thing can happen. D can be greater than 0, but now if it's a non-perfect square, that's going to change things just a little bit. Now, it still means that we have two roots, but now they're going to be irrational roots. Okay? All right, now the third option we could have is that we could have the discriminant be equal to 0. And if that happens, it essentially means we have one root, not roots, it would just be one root, and that root would be rational. All right, and then the last option we could have the discriminant be less than 0. Now, if it's less than 0, basically we end up with two roots, however, they are both imaginary. Okay, so those are all the different options we could have. And now this is going to be the part that comes into play when we choose our methods. But first, let's just see if we can use this table and figure a couple of these out. Like, let's say I have 2x squared plus 12x minus 13 equals 0. All right, so the first thing I want to make sure I want to make sure everything's set equal to 0, which it is. And then I'm going to find the discriminant. So d is going to equal b squared minus 4ac. So for us, that would be, let's see, b is going to be 12. So we would say 12 squared minus 4 times a, which is 2, times 13, and actually it'd be negative 13. Now, that's going to give me, let's see, d equals 144 minus, and actually it would be plus because these two negatives will make plus, and it would be 104. All right, so d is going to be equal to 248. Now, here's what we know immediately. This is a positive number, so it's greater than 0. Now we have to decide, okay, is 248 a perfect square or a non-perfect square? And it's not a perfect square. Okay, which means here's what this discriminant tells me. I have two roots, so two roots, but they are irrational. Right? We'll talk about what that means in a little bit, but essentially, this is, I guess, kind of a teaser for that. We probably aren't going to be able to factor this, all right? But let's continue. Let's do another example. Let's say I have negative 4x squared plus 84 equals 10x. Now, the first thing we want to do is make sure everything's equal to 0. So we're going to subtract 10x, subtract 10x. So negative 4x squared minus 10x plus 84 equals 0. So now we're going to find the discriminant, which is negative, or it's b squared, so negative 10 squared minus 4a, which is negative 4, times c, which is 84. All right, so this is going to give me, let's see, 100 minus, that would be, actually it would become plus, because minus, it would become plus 1,000, wait a second, 1,344. All right, so the discriminant is 1444. And I actually could do the square root of this. It is a perfect square. So that means that I have 2 roots, and those roots are rational. Now, typically, that means we could probably factor this. But once again, that's kind of a teaser for at the end. We'll cover that in a second. So let's do one more. Let's say I have 3x squared plus 24 equals 0. All right, so now this one's a little bit tricky, but everything's equal to 0, so we can figure out what b squared is, except in this case, b squared is 0 because I don't have a bx term. So that means the coefficient is 0. So now I'm going to say 0 squared minus 4 times 3, which is a, times 24. Now, if this is 0, that means d is going to end up being negative, because I'm going to do a negative 4 times 3 times 24, which is going to give me negative 288. Now, it doesn't matter if this number is a perfect square or not, because it's negative, which automatically, if the discriminant is negative, it means that you have 2 roots, but they are imaginary. All right? Now, here's how I always try to explain it. Remember that b squared minus 4ac came from under the radical in the quadratic formula. So if I were to do the square root of a negative, it is imaginary. So that's where some of this comes from. Now, the next question is, how do we use all this to choose the correct method? So here are our methods, and I'll try to give you a little cheat sheet for how to choose the correct method. We have factoring. That's a method that we've looked at. We have square roots. That's a method that we've looked at. We have complete the square. So complete square. And then we also have the quadratic formula. I'll just write that as QF. Now, here's how I know when to choose each of these methods. And actually, I won't even try to make it neat. So I can use this method of factoring sometimes. Now, here's when I want to use it. I want to use factoring when I have roots that are rational. So if you think back to some of the examples we just looked at, for I think the second example, we ended up with 2 rational roots. That means that we could factor that, and it would be a fine method to use. So when your roots are rational, that's a tip-off that you want to factor. All right? So now, square roots can also be used sometimes. So sometimes. All right, now, here's when you want to use this method. This method can be used pretty much any time when there is no bx term. All right, so the roots can be rational, irrational, imaginary, but if there's no bx term, that's typically a tip-off to use square roots. All right, the last method, or I guess the second to last method, is completing the square. So this can actually always be used. However, there are times when it's better than others, so I'll try to lay that out for you clearly. So you want to use this when there's no x squared coefficient and an even bx term. All right, so if there's no coefficient in front of x squared and you want your bx term to be even, that's a tip-off to use complete the square. And then the quadratic formula can always be used, but we want to use this as, I don't know, a last case scenario or last resort. Okay. Now, for some people, they just like to do the quadratic formula and they'll use it as the first resort. But if we're talking about efficiency, which just means doing things as quickly as possible, we basically want to go through factoring square roots and complete the square before we do the quadratic formula. Now, what I'm going to do for this is upload a separate video where we use this to pick the correct method to use. But I think this video has already been long enough, so I'm going to put that in a part 2 for this, for the discriminant and using the discriminant. But if you keep all these things in mind, it will be super helpful.